Algebra, Algebra 1's going to see that video come in at an hour and 45 minutes and be like, what? Okay, so hold on, y'all. I am not in my groove yet.
And be like, forgot to teach this.
Oh, they would die. I give them enough panic attacks as it is. Poor things. Because they got me as a teacher. Hold on 1 second. I'll get my junk in gear in a minute. Oh, yeah. We need to review those again, but not today. You all missed geometry, didn't you? I know you did. It's okay.
And then I was like, what do I think? It was a good break.
I did sit yesterday thinking like I have no score to do, so I was just like, I'm gonna do.
I
Well,
could have gone for like 5 problems a day of like a review, and that would have like probably counted to like future problems. I mean, future work.
I have to remember that for the future.
That's just me, so I don't speak for everyone.
Y'all give me just a second. Okay, so y'all, this section is space figures and nets. And you all already know that's not fishing nets, that's in the world of geometry. So go home tonight talking about polyhedrons and impress your parents. Makes you sound very intelligent. 3D figures whose surfaces are polygons. So we're going to be looking at polyhedrons, 3D figures whose surfaces are polygons. Now, I am not the best artiste, so bear with me. I'm going to try to draw a 3D figure to the best of my abilities. I'm going to start with a rectangle, and I'm going to send out these diagonal lines, and then I'm going to connect and hope that that looks somewhat three-dimensional. So just a reminder, we've kind of already talked about it. Think about that little cereal box. What are each of these flat figures called? Y'all remember? Yeah, good job. So that's a face. And the face, by official definition, is the polygon of the polyhedron. And poly means what, y'all? Yeah. So these 3D figures are made up of many polygons. So that's a face. That's a face. You get the point. So this has got several faces to it. Do you all remember what we called, let me highlight it, this part right here? Edge. Good job. So several edges to this as well. And the edge is the intersection of two faces. Okay. So again, this face, this is where they intersect in that segment right there. Okay. And then do y'all remember? Let me do the black. Where you've got an edge, an edge, and an edge all coming together. What is that?
Vertex.
There you go. And the vertex is defined as the point where the edges intersect. So as we get into this whole chapter, 3D figures. We're going to be doing surface area, which would be like finding the area of this entire net, for example. We'll be looking for that surface area, and then we're going to be going into volume. How much does this hold? So we're going to be using lots of these terms, the faces, the edges. I'll get into lateral area, slant height, all that. So make sure that you take note of all these definitions so that I don't throw you with something that I say. Just go ahead and realize this is not hard, just a little bit of new vocabulary. A net is the 2D pattern that you can fold to form a 3D figure. A 2D pattern that you can fold to form a 3D figure. How much time we got? Because I want to do a lot today. Okay, why don't you all look in your books at page, be getting them out. And again, thank y'all for bringing those so faithfully. Okay. I don't think I'm going to have you draw a ton of these. I'm on 303. I'm not going to have you draw a ton of these, but there are a few. Oh, stink. Sorry. I had some easy peasy worksheets for you all to do that I left on the printer at home.
Oh,
Can you send us the thing and we can print it out?
Thank you. Sorry about that. I was going to say there's only 3 or 4 of these, so try really hard to draw a nice net on the 3 or 4 that I assigned. But would you all break up? You don't? Well, I may still send a picture and then you can just look at the picture and put your answers on another sheet of paper. And again, my apologies. I wanted that to be super simple and easy for y'all, but yeah. Would y'all please, for just a minute, break up into 3 groups. 3 groups. And yeah, okay. Guys, get together, and ladies, will y'all split up into 2 groups? Guys, will you get out a piece of paper? I don't want to do this. I'll tell you what. Each of you take one. Baron, will you get figure number 1? Bennett, get figure number 2. Samuel, will you get figure number 3? Draw this out. Does not have to be in your notes.
Big?
Separate sheet of paper. Do it big. Do it big. Draw this out and cut it out, and then you will fold it. You're going to have to fold it, and then show your 3-dimensional figure. Yeah, pick one each. Do the same thing. And then y'all just pick one of it. Don't do all 3. Pick 2. And so, like,
How big?
you go get one, Hallie. You might want to do I'm really regretting not bringing cardstock. See if regular paper will do it for you. Again, because while you all are doing that, in a minute, we're going to be matching some of these. So you're going to be looking at, okay, which of these forms a pyramid? And do you see how your brains are going to kind of have to work to fold these in your head? Is that going to make a pyramid or no? So I'm just trying to get your brains to move that direction to where you take something like this and what does it make when you fold it together 3-dimensionally?
Cutting it out.
Yes. Again, make it big enough that you can fold it and do something with it. I think that'll work. I think, try it. Usually I try this stuff before I ask y'all to do
Can you
it.
go back to the other picture?
Yes. This may totally fail, but that's okay. We'll try.
Oh, it popped up on my thing, and I was like, oh, look at this, then. Yeah, like.
If anybody wants to be brave enough to try to tape it together.
What,
Yeah.
Okay, so you got this. So now, okay, I'm gonna use Amelia's, okay? She's got this drawn. So now we're gonna fold it.
Let's get it.
Who has this?
It's not awful at all. Okay, so here's Amelia's. It's a little wonky, but mine would be too. What's that forming? Yeah, a pyramid.
I don't know what's gonna hold it.
No, you're
Do the best you can. You're on your own, Samuel. No, so there you go. So again, just trying to warm your brains up to thinking 2D or 3D. So try to do that. Good job.
So cold.
You may have made yours too small. I don't know. She said we could make. Did you really? Yes.
Is it working?
It's not bad. You know, like, it's like, you have to have something pretty warm. Yeah, jackets and gloves are nice.
Yeah, we have so much.
Yeah, I'm pretty comfortable with you all. So I did a little bit more
Yeah.
I could cut up.
It's a candy bar that's
One
packaged
fell.
this way.
Oh, Toblerone.
Yeah. Here, I'll let you-
Wait, I know how to do it. Yes.
Look at Walmart the next time you're there. What's the color of the package?
It's tan. It's tan.
With red letters?
Yep.
That's. the-
Tan with red letters. Look, and that's how they package. And if you think about it, I wish I thought about this. I wish I bought like enough for all of you all
Do this.
Yeah.
So it's like-
and show you how
The
well they
rectangles-
pack together.
The rectangles
in a
go
box.
in each other, like, let's say this is a rectangle, this, they go like that to a triangle, and then the little.
Okay.
Well,
Two
see, wait,
travel.
did you do it? Oh, sorry. It's like, oh, see, did they ever make the total?
Oh, look, this is a little square package.
Oh, you're
It's
making.
got adorable.
Thank you.
Mine's gonna be.
Toblerones. They're so good.
It's not.
Okay. So, yeah, I didn't even think about that, but that's how a candy bar is packaged. Okay, do y'all see
They're like
Sam's?
chocolate with nuts in them.
This turned out really well too.
I think it's got.
Okay. Again, and the beauty of this, like if we had the time and could get really practical, if you're making a product and you gotta package it, you also wanna figure out how you can fit the most in a box to be shipped. And so this package would be really effective, so I can see why they did that.
I can see this, I think square should be better though.
You still think so?
Yeah.
Could be a packaging engineer.
It was.
Yeah.
It doesn't like, it keeps playing on some big songs. Like,
Oh, what else you got? I've seen a couple. Did you do the Toblerone or whatever? I actually had that candy bar.
It's
Today.
here.
It
They're so fun.
Yeah.
So good. I don't know.
I'm gonna have to go look for one now.
I don't like.
So you, that's what you.
They're hard to
Like,
find. But how much money do you think you do?
I don't want to write all my stuff down. That's my problem.
Made it.
I don't like writing.
$10.
Okay, y'all gonna think I'm goofy, but when I look at your notebooks, I tell you what, would you all put this in your notes? Unfold it, go back to your notes and tape it in there. That's an example of a note.
Oh, you want us to take?
Yeah. Now that you've shown me the 3D, oh, did you go ahead and tape it into that shape? Now unfold it back and now put it in your notes. No, good job. They're so cute. Aw, so cute. Put your nets in
They
your.
are so close. Yeah.
Wait, we put more tape in there?
In it.
You didn't undo it.
I didn't make one.
Sorry.
See,
I want to know what it must have been.
nice job.
Where's mine?
Good job on your nets. I'm very impressed. Now, I'm sorry to make you unfold them and make them two-dimensional again, but put the 2D net in your notes.
We're gonna make somebody catch a bunch.
Nice job.
I just wall.
Good job. Those look great.
Yeah.
Not any better than my truck.
Oh, and I just ran out of tape, so y'all can buy our glasses. Who doesn't have any tape?
I don't have any. But I don't think it's wasted on this pyramid.
I got it.
There, it's part of your notes. That's all I got.
I'm sorry.
Oh, you had to put it in your notes?
Yeah, put it in your notes.
Oh, okay. Can we fold it and put it
It's
in our?
one of your favorite days of geometry.
Probably took all this.
To treasure, to frame, to always remember.
Okay, let's keep going. So y'all, a little bit of in-class stuff. Nice job on those. I'm not even gonna make you do this for homework. This is hard for me. I'm just gonna be honest. I'm gonna cover it and see what you think. And I'm not proving it. If you want to like draw out your own, go for it. Which of these makes a pyramid?
A
A. We all agree on A, right?
and D
And D?
and B.
D.
No, not
What?
B.
D does not.
D does make one.
Okay, let's get your final answers. B. Does B form a pyramid?
No. Wait, no, B does not.
Yes, it was. Yes, it
B
does.
does not.
It doesn't.
B does not. B does not. B
They
does.
say B does.
They're wrong.
And that one.
No,
What do you think about C? Who says C?
no, I'm gonna say just be different. No,
No.
yeah,
D?
Yes.
no,
Yeah.
Yeah.
no.
Yep. And you've already seen all the other answers. Crud. This is so hard to do. I would have to draw it out.
I'm gonna draw it out
Let's-
just to prove you.
On the thing, it won't flip on the thing.
That was very important.
It won't flip on the thing. No, there's. no
Okay.
way.
So
Finally, give me a second.
If they're equiangular, it would. Well, they're not, and so it's wrong.
God, y'all can see all the answers.
Wrong. It's D, what was D, was it?
D is a pyramid, they're saying. Okay, so just hints on this. Look at number 2, because you will have some of these on the worksheet too. Can you see how this matches B based on some of what y'all just did?
Yes.
Okay, and you all, yeah, Samuel was one that did this, and did you do that also, Julia? You all did that one, so that matches D 3-dimensionally. And if they get a little bit harder, use clues like this. Like you see these faces are rectangles. What shape is the base? Hexagon. So you can see the rectangular faces here, and then here's your hexagonal base. So you know E goes with 5. So just look for hints like these to help you do these. And like 6 and 7, what's the key difference here? What does 6 have that 7 doesn't? Square base. So you know that's why C goes with 6, because of the square base. So that's all. Again, I hope those were kind of fun when you do them. I will send a picture of that homework out in a minute. But let's go ahead and let's do one more thing today. That's all I'm doing for 6-1. The next part, and this is part of your notes, page 307, algebra review,
Quick red thumb.
please, part of your notes. And this is going to be homework. Okay.
Separate page.
Yeah, put your picture on there and start fresh. It's easier for my eyes to see too. Okay, so this is going to be, I just want to go back and practice some dimensional analysis. Dimensional analysis used a lot in math, chemistry, etc., environmental, all that.
Wait, so I should put this on a different paper and turn it into you separate with like.
Well, this is notes. This is still notes. Yeah, so what else to call it? Page 307, algebra review. And I'll tell you what, 362 notes. Okay, before we get into examples, let's go ahead and write down some, I'm blanking on what they're called. Well, anyhow. 60 minutes equals what? 1 hour. Yeah, so let's go ahead and build up some of these to have for reference. Yes, conversion. Yes, conversion units and stuff. 60 seconds equals what? 1 minute. Okay, right? And just as we're doing this, notice the equals. So even though they're different units, they're the same amount of time, right? 1 hour is equal. It's the exact same amount of time as 60 minutes. Yes? Just different units. So realize that as we're doing this. So 12 inches equals what? 1 foot. 3 feet equals good. Yard. And there'll be more. We'll add to this as we realize we need them. Now let's hit a little bit of metric stuff. Okay. 1 kilometer equals,
5,000 meters.
what's kilo mean? Kilo means 1,000. Good job. So that's 1,000 meters. 1 meter equals how many centimeters? 100. Yep, because centi, like century, means 100. What's one more? 1 meter equals how many millimeters? That would be, I think, deci.
Is that what there's always.
We're not going to get too deep into this because we don't have time. Okay. Whereas it takes 1,000 meters to make a kilometer. Like a kilometer is close to a mile, right? Okay. Now break a meter down into smaller parts. A millimeter, it takes 1,000 millimeters to make 1 meter. Okay. I need a ruler.
Like 12 versus 1.
There was like a Saturday Night Live.
Oh, they forgot.
If you find that, send it out to us.
I mean, Big George Washington.
Yeah, that's not forgetting. And
Those
it's
are-
like- And we will have,
Why didn't we change our metric system?
because we were.
We wanna be-
Oh.
We're different. We're rather than the.
Then
So we made everything. And the Brits, so we left and we were like, we're changing everything. That's what.
Oh, yeah.
Pretty
Pretty much what we did. I think you can see this. Yeah.
No, we just made everything so complicated for ourselves.
It's better than like
Oh,
the British people going like 5 stone, and that doesn't make any sense, but then we'll be like, no, it's this much pounds. Yeah, but they use stone. Anyway.
Well,
I feel like
anyhow.
we made more sense.
My father was into electronics and he was always fussing, like, we need the metric system. He said all of this was so complicated. But yeah, he said metric is much, much easier. So here's a centimeter, y'all, right there, centimeter. Takes 100 of those on your ruler. It takes 100 of those to make a meter. And then just for perspective, a millimeter, you see that? That little thing is a millimeter, millimeter, like they're tiny. Okay, anyhow, I am all over the place today. Let's go ahead and just remind you how to do these. They come in handy. So, what time is it? We're doing okay. Okay, we're gonna start super simple. Convert 7 hours to minutes. Okay, now I will say, if you did Saxon Algebra 1, you're probably really strong on this. But if you didn't, I'm gonna try to get you a little bit more firm and confident. So you've got 7 hours, and it may be easier. Let's say that's number 1. Let's put it over 1. Okay, we want to go from 7 hours to minutes. So I think this one's pretty obvious. We're going to use this one right here. And before I go any further, realize you can write this as 60 minutes over 1 hour. And that's like writing 1 over 1 because they're equal to each other. Or you could write this as 1 hour over 60 minutes. You pick the one that's going to help you the most. So what you're going to do for this one is you want hours to cross eliminate. So I'm going to pick this one right here. times 60 minutes. Sorry, not M. That looks like meters. Put MIN for minutes. 60 minutes over 1 hour. And again, we can do this because this is equivalent to what? 1. We're just multiplying by a value of 1 because they're equal to each other. So when you do that, the hours cross eliminate and you're left with the unit you need, which is minutes. So 7 times 60 multiply straight across, you get 740 minutes over 1, which you don't have to put, just put 740 minutes. Okay, so that's your first, that's kind of warming you up. You good? Okay, so let's take it up a notch. Number 2. Where's another good one? Okay, let's do 3 feet equals blank inches. Okay, so we're going from feet to inches. This is another pretty simple one. So put 3 feet over 1 if it helps keep you balanced. And then find the conversion units that you need. Feet and inches. See how it's going to be that one? There's 12 inches in a foot. So do I put, y'all, the 12 inches in the numerator or the denominator? Numerator, 12 inches in 1 foot. And the reason Bennett did that is because he knew that the feet would cross eliminate. And that's what you're aiming for. We're left with inches. So multiply straight across. 3 times 12 is 36 inches. We don't need the 1. Just stop there. 36 inches. Okay. So you will have some simple ones like that. Then you will have some to where they give you like yards to feet. And they're asking you which conversion factor to use. So, oh, how do I say this? Give me a second so I can try to make it clear. Let's say they give you 3 feet and 1 yard is option A. Option B is 1 yard and 3 feet. And you have to pick if you're going to use A or B. So maybe think about it this way. If you have yards and you got to multiply it by one of these, which one is going to make the yards cross eliminate? Hey, y'all see that? If you do the 3 feet over 1 yard, the yards cross eliminate. So you would pick A as your answer. That kind of makes sense? I know it's okay. Let's keep going. Try just to get you warmed up. Try to convert 5 meters to centimeters. Now, I'll be honest, there's easier and quicker ways to do it with the metric system. Okay, you'll probably get into that with chemistry to where you can just kind of go up and down on where to move your decimal. But for the sake of dimensional analysis, we're going to practice it this way. Okay, so y'all tell me, what conversion did you all use? Unit conversion. 100 centimeters equals what? 1 meter. So what did you put in the numerator? 100 centimeters. And what went in the denominator? 1 meter. Good. And you did that. So those cross eliminate. So how many centimeters do you have? 500. You got that? Good job. And if not, just don't be intimidated. You can do these. Let's do one that's going to take a little bit more. This time, go from millimeters to centimeters. Sometimes it's easier to do 2. So I would probably go millimeters to, well, you could do that on your head too. It's okay. Let's do it this way. Go millimeters to meters, then meters to centimeters. Just in case you ever had just a total brain lapse and you had to go totally to the basics. I would say go millimeters to meters and then meters to centimeters, just in case you forget all other. Because I'm thinking, I know with just a decimal where I would move it. But that's okay. For a meter, how many millimeters? 1,000 little millimeters
Wait,
in a
what's
meter.
that?
There's 100 centimeters, sorry, in 1 meter. Oh, it's hard coming back from break. So for this first one, where would you put the 1,000 millimeters? Sorry, y'all, I left off an M, my bad. There's 1,000 millimeters in a meter. So where do you put the 1,000 millimeters? On the bottom. Good job. And then that meter goes in the top. And so what would you do next, class? Let's eliminate. Okay. Now we are to meters at this point, but we still want to get to centimeters. So let's use this one. Times. Now, where do I put the meter? Numerator or denominator? Denominator. Good job. 1 meter and the 100 centimeters goes on top. And again, what do we cross out? Meters. So we are down to centimeters, which is what we wanted. So be careful here. If you go across the top, you're going to do what? Multiply. So do 19 times 100 and then divide by 1,000. So when you do that, 19 times 100 divided by 1,000, or you cross those out, you get 1.9 centimeters. And again, other ways to do that, but we're just practicing dimensional analysis right now. Y'all? Okay, one more. Let me show you another one. 6. Let's say I ask you to convert 8 feet squared to square inches. Okay, this one takes it up a notch because it's not just feet, it's feet squared. Let's wrap this up. So my recommendation for that, and this is Saxon style for those of you who had it, is to write 8 feet squared as 8 feet times feet. Right? Feet times feet is feet squared. Times, now let's use this. How many inches are in a foot? Okay, 12 inches and 1 foot. So you would just, to counter the feet and the feet, do this twice. So times 12 inches over 1 foot times 12 inches over 1 foot. I think we even did this up to triple. If you get cubed, handle it the same way. So notice feet and feet cancel out. Feet and feet cancel out. You've only got ones in your denominator, so you're just going to multiply straight across. What's 8 times 12 times 12? Seems like it should be higher. 12 times 12 is 144.
Oops. I added that.
Yeah, no,
I guess. Well, 96.
I'm trusting you. And then go ahead and take it back. Y'all, what's inches times inches? Inches squared. Okay. Now wait, that's not matching my answer. Isn't that somebody else with a calculator? What's 144 times 8?
Oops, guys, I did it with a 9.
Okay, we are firing you.
To be fair, I am not eating food today.
Okay, then yeah.
11:52.
Okay, thank you.
Oh,
Okay. I don't know. Is that too bad?
apparently for
Okay.
better.
You need food. That's all we're gonna do. Go ahead. I need to send a picture of this out. Page 307. You can do this. Go ahead and do 1 through 19. Yes, all.
bringing it back easy.
The works, okay, consider this Thursday's work. Wednesdays, I'm gonna send you a picture of that worksheet, and I don't think it's gonna take you 10 minutes at most.
We have to show all of our work translation.
I wanna see this right here.
Okay.
Yes, please,
But
please,
it's
please,
like
because
The first one where it just converts 7 hours, 10 minutes. I guess, actually, no, that's so easy to write.
yeah, if you don't mind. Now I can see on 1 through 3 where you don't have to write anything. 1 through 3, you can just give me A, B, or C, or A or B, A or B. But for 4 through 19, even if they're short, will you show it just to practice it? I mean, this isn't just math. If y'all go into science later, any of your science classes, I want you to be able to do this. It's kind of a lot of pressure for a math teacher to make sure I prep y'all enough. Yeah, go ahead and do that where you can help each other. Start on that, and I'll get that picture of the worksheet sent out to you. Hold on.